I'd like to introduce Ian Hellen. Ian Hellen is a principal security engineer at Microsoft, where he's working on security detections, investigations, and hunting. His specialty is working with Python, Jupyter notebooks, and has contributed to various online security cloud services, such as Azure Sentinel and Azure Security Center. Please join me in welcoming Ian.
Thank you. So one of the problems with talking last in the day is everything's already been said. Even my introduction has already been given. So with that, I'll conclude and ask if there are any questions. So I work mainly on Jupyter notebooks, and Ram, when he asked me to do this talk, I said, well, I don't know much about graphs. I mean, Jupyter notebooks, Python. He said, no, it'll be good, it'll be good. Graphs, investigations, hunting, you should do it. So here I am. There'll be a thin layer of graphing within this. So the quote has already appeared. I remember when I first started working in kind of like computing, I thought one day it would be great, if I could work for somebody who was so famous that his or her quote would appear on somebody's T-shirt somewhere. And I was able at BlueHat this year to tick off that particular bucket list item as John Lambert's Attackers Thinking Graphs appeared across the floor. The other thing about it is that the Defenders Thinking Lists, I think today is shown us that that's not necessarily true anymore. I mean, there is still a problem that much of the data that we still give them is lists, like tables or things like that. So people are often forced to think like that, but there's a lot of possibility for like visualizations, both graphs and other kinds of visualizations that allow you to think more holistically about a problem. I should have shout out to two of my colleagues, Pete Bryan and Ashwin Patil, who've we work on notebooks and Python libraries together, do some very interesting stuff, write some nice blogs. So it's been said a few times, like every attack is conceptually a network, a graph, where nodes in the graph or entities and essentially the verbs, the actions between them, or the links between them are the edges in the graph. So if what we're after is our attacker graph, I mean, how do we get to it? So the problem historically was we didn't always have the telemetry. We had like, back far enough that the telemetry we had was like a firewall log and very little else. Now I think it's arguable that telemetry is not a barrier. We have, in some ways, maybe too much data, but very rich data from like agents that can tell you about individual changes to registry keys or configuration items. Lots of very interesting and useful data from cloud services. So the problem comes more like down to how can we extract the graph that we want from all of this data? And I think there are three things. So there's three ways of trying to approach that, because when we think about every legitimate operation is also a graph, like how do we identify what our suspicious subgraph is? There are a couple of things we can do. So we can start appending, and a few people have talked about this, like Matt Swann particularly, gave a really interesting talk about this, about using other attributes, maybe things like detections. They could just identify a particular node, or they may be more sophisticated detections like time travel logon detections or multi-process kinds of detections that will identify multiple nodes or entire subgraphs as suspicious. We also have some kind of inference that we can do as analysis within our notebooks or other kinds of analyses where we can label particular edges or nodes as suspicious. So that would like distinguish our attacker graph from any other subgraph within our huge array of data. The second thing is that there's known bad things where things are indisputably bad. So you might have a lot of false positives in a detection, but if something appears as a known C2 IP address in TI, and that appears in your graph, then you're pretty much done. The final thing is just looking at the graph itself. And is there something about the linkages in the graph that are anomalous enough that we don't need to have any of this other data? We can just say definitively this is like a bad thing. That's a difficult thing. We have tried to do that. I worked on a project a couple of years ago looking at data on our corporate network, where we were looking at host logons, lateral movements from host logons, and like terabytes, maybe more than terabytes of logs, like processing all of these things and looking at unusual. So user A logged on to host 1, then host 2, then host 3, and so these kind of like chained logon patterns. And we were able to define, I'm not sure whether I should be talking about attacks within Microsoft, but we were able to define fairly definitively that a certain subset of these chains were attacks that we discovered by some other means. So there is a lot of value in that kind of thing. The problem with it, even though it's not really intuitively appealing, is that it's very computationally intensive and kind of difficult to do for most people. So most of what I'm trying to do is looking at the first two of these, like either alerts or inferences, or known bad nodes and edges as a way of helping us identify whether we're looking at a bad graph or a good graph, really a subgraph. There's one side point I want to make about this detecting kind of anomalous graphs. I think it is a really interesting area, and some of the speakers have talked about this already. And I've forgotten this guy's name, but he works or used to work for Google kind of internal security team, and he was looking at using, or their team were looking at using natural language processing, which I thought was a really interesting thing. So every entity is like as a kind of a part of a sentence, essentially given to the language processor, and a whole like subgraph or a path of like different actions is a sentence or a paragraph. And if you learn the model, if you pass the model of your network, it can kind of learn the vocabulary, the syntax of your network's language. And then when it sees something that either a word that it doesn't know how to spell, this is like a word that doesn't exist in our language, or some syntactical or grammatical error in one of the things, then it can identify and say, this is an anomalous thing. This doesn't exist in the language that we've come to learn about our network. So even though I don't know much about that, I think that was a really interesting approach. Right, so Jupyter Notebooks. So this is primarily a talk about Jupyter Notebooks. And Colin's great presentation has stolen a good bit of my thunder, but I think there are a lot of advantages of Jupyter Notebooks they come from the data science world, or the science world, really, pure science like astronomy, genomics. And it's still true that one of the most common investigator tools is Excel, like sets of spreadsheets. And the problem with that, or even with like query language, like in Azure Sentinel, the log analytics query pane, if you're doing an investigation, you build up a whole set of queries. Something happens, you forget to save them like I do. I'm not like a very frequent saver. Your browser crashes or something happens, and all of that work has been lost. So they're kind of fragile, they're difficult. I think as Colin said, they're difficult to kind of repeat. Like if you want to do that analysis again on some other case, which can you do? And it's also difficult to present the results of the data. Whereas notebooks are kind of the opposite of that. Something you can execute a pattern over new sets of data, reuse different subsections of that. Yet you can easily modify it if you need to do something like, oh, well, in this case, I want to go and look at a separate bit of threat intelligence. I can go and do that and just add it into my notebook. The great thing about it is it persists not only all your queries, but all of the data, the results from the queries in a single document. And it's a document that you can end up like sharing. Non-technical users can understand, can see the results, particularly if they're kind of like visually presented or nicely presented. One other kind of cool thing about it is that you can use it instead of PowerPoint, which I really like. So that's what I'm doing at the moment. So notebooks, I think in the way we try to use them, we build notebooks to help with investigations and hunting. What we're mainly focused on is trying to avoid data overload, data fatigue. So rather than having to trawl through logs, can we do things that make it easier for an investigator to pull out the information they want to? So using things like visualization, different analysis techniques, and I'll look at a couple of these. So I think there's also a danger with like graph like data overload, and a number of speakers have talked about this. I think Gabe early on, like these amazing kind of pretty graphs, but like what does an analyst make of that? It's very difficult to like get any actionable information from it. But I think with using something like notebooks and the same approach that both Colin and Matt Swann looked at, you can use notebooks or this kind of gradual process to filter out your data when you're looking at a particular entity or pattern, and build the graph from that. Actually, let me switch over to another notebook. So this is, I'll talk about these a little bit later. We've got a series of notebooks that are entity explorers. So this is one looking at a Windows host. And I'm hoping this executes. This is always a danger of doing like a live thing, but here we go. So this is querying Azure Sentinel to get, for our host, we've given it a name and it's found the host. And we're looking at ways of presenting logon information. So this is like an interactive timeline. So it becomes pretty easy to see which are the very frequent logons. We can get rid of, we can zoom into maybe some things that we're interested in particularly. I didn't click on that. There we go. We can zoom into timelines and look at things like that. So it's a kind of like simple thing, but a very quick, a very useful way of like grasping what is going on, what's been going on in the last like 3 or 4 days on this machine. And also a way of like summarizing logon data, so we can very quickly see for things that we might be more interested in, like network logons, remote interactive logons, terminal services like logons. We can see which are the accounts that are involved in that. We still don't know anything about them. We can, so even though we can view this set of logon sessions, see how many of each type has been there, we want to really know, is there anything that makes it worthwhile for us to look at this session? And ideally, we'll pull out that data directly rather than have to go and dig through it. So we can look at the user types, the SIDs and stuff like that. But something more interesting we can do is look at all of the processes that are happening in this session, or each of the sessions, and calculate a rarity index. So one of the problems with using machine learning on security data typically is the data we work with is some dates, very rarely numeric data, mostly text strings. So one of the tricks in being able to do this is like how to extract the right kind of data, turn it into a representative number. Once you've done that, you can then start doing interesting things. So here we're taking all of the processes, process command lines, reducing them to kind of repetitive patterns, removing some of the kind of uniqueness of the patterns like GUIDs and IP addresses that are embedded, but looking at the pattern and how often it's repeated. So then we can compute a kind of rarity index. We can cluster that data, and the rarity is like the inverse of the cluster. So the larger, the greater the number of processes that group into a cluster, we'll say that's a very repetitive thing. It's probably not very interesting. So I won't actually run this now because it takes a couple of, not long, like 30 seconds on this laptop probably to run, but having done that, we can then see that the vast majority of our, I think of like 26,000 events, the vast majority of these things cluster, they're very, very common and uninteresting events. And we have a few sessions at the top that are kind of rare and kind of things that we want to look at. And we can browse down to those things and see the content of them. So our thing with the highest rarity has, probably what we would think are fairly rare items like creating users, manipulating groups and things like that. And conversely, we look at something lower down the list. We get these very kind of repetitive things. So it becomes, you could almost automate like the, skimming the top layer off this group and saying we just want to kind of look at that thing. Final notebooky thing is, I just want to show you some of the tools we're kind of like building. This is a visualization of network flows from the same host, looking at categorized by layer 7 protocol. So very quickly you can see, well, NTP and HTTPS, if you can read that, they're relatively common things, but there are some more sporadic things that like kind of jump out at us. And we can see that looking at inbound versus outbound on the second graph, that those more sporadic things also correspond with these were inbound network events. So in particular, one interesting one here is the inbound SSH and inbound terminal services stuff. Okay. One thing I didn't have in the notebooks there was another thing we use is time series analysis, and I can't remember who it was who talked about this, Josh, I think, earlier on. But this is another thing where you can identify, like, within a vast kind of trove of data, if there are particular segments of time where you want to kind of pull out information and activity around those times. So here we see like these seasonally adjusted anomalous amounts of network traffic. Okay, so I said that most of what we're doing is these Entity Explorer notebooks, and the premise of these is that if you're hunting or investigation, you'll have some kind of data, but usually not enough to make any conclusion about it. So the idea of these is you can take an entity from those, a host, an IP address, a URL, something like that, and it gives you a very quick way to drill into that and pull out useful information. Well, we hope it's useful. Alongside this is the Mystic Pi project package, Python package. And this is a kind of container for a lot of this kind of gnarly code that we don't really want people to have to type in or even like paste in. That we've encapsulated a lot of these things into an open source package, Python package, and some examples of things like that. I mean, to say it gives you superpowers is probably a bit of an exaggeration, but it gives you things that are a little bit like nice time savers. So rather than having to type in this kind of rather nasty bit of code, and that's not all of it, you really just want to say, sum it up, well, show me like a pivot of like logon types by account. We've seen another kind of superpower X-ray vision of visualizations, and I think these are very, very powerful. You know, the human brain is really good at picking out patterns of things if it's presented with data in the right way. And some of the analysis techniques like the clustering and the rarity index. A couple of other things that we have packaged are things like being able to decode encoded. It's very common for attackers to kind of like obfuscate their intent by encoding either base 64 or often like nested, like zipped base 64 encoded, gzipped, then encoded again. And one of the things we've got is like a library that you can take an entire data frame full of command lines and send it to this thing, and it will do all of that kind of decoding. It's not a huge thing, but like a nice time saver. Similarly, there's a thing that will do the same thing with large quantities of data and pull out IOCs, so like IP addresses, URL patterns. So you don't have to like try to remember or try to find from regexlib what's the URL pattern you need for a domain name. And of course, if you've got IOCs, you'd want to look them up in threat intel services. And you could go and copy and paste IP addresses into VirusTotal. But what you really want to do is just say, well, VirusTotal, I'd like X-Force, Alien Vault OTX, maybe the Azure Sentinel, bring your own IT. And I just want to look it up at all of those things. So there's another library that's a kind of wrapper around these services. So it allows you to build a very, very kind of quick workflow to try to go from potentially encoded content within a HTTP request or a command line straight through to, is there some threat intelligence threat intelligence indicator within this data. So I've talked about lots of things that went graphs. I'm going to get back to graphs, and in a very modest way. They're kind of like small graphs, and I was very heartened when one of Gabe's very early graph examples, he said, this is a bit of a horrible graph, but it's actually really good. So most of my examples are really horrible graphs, and they're very modest, but I hope you'll get the idea of what we want to do. So this is another example of these entity explorers. This is the account explorer, and again, I'm going to take my life in my hands by running queries to Azure Sentinel. Did I do that? Anyway, so this is just pulled back I've given it an account name. This is me in this case, Ian, and it's found the logon events. It looks in like Azure Activity Log, Azure Sign-in Log, Linux syslogs, Windows logs. So all I know is there's an account called Ian I want to look for, and it will go away and find where is Ian in my enterprise. And the first thing he does is just build a very simple graph. So Ian here, seen as logged on to this, most recently logged on to this machine from this source IP address, and this was in a couple of cases, this was the subject account name in Windows terminology. So having had that, we would probably, are there any alerts related to this Ian character? And we found a couple here. Nope. And adding those to our graph, we get something. So we just attach that. We found an alert automatically. We can just automatically add that to our graph without any thinking about it. And that immediately makes our subgraph somewhat suspicious. We have, could be a false positive, but it's something that's strengthening the case that this connected set of events are something that we are interested in. So looking a little bit, a bit further, we've found now that we're having a look at the host that we've seen the logon happening on. And we can do a threat intel lookup for the IP addresses that we've seen as source addresses for the logon on this host. These are all from the same place, so they're represented as a single item on the graph. It's a little bit more complex now because we've added like a couple of other IP addresses, and we've seen this is slightly fabricated data, but you know, in this case, X-Force probably wouldn't have identified all three of those IP addresses, but for the purposes of the discussion, we've now got a really fairly solid case that not only do we have an alert firing from one of our hosts, but from one or more of the source IP addresses. This is a kind of a known dubious address, possibly a C2 address. We can also add descriptive information, so we can go about these IP addresses. We can get the, relatively quickly, we can go and get the ASN, like who owns the subnet block of this address, and the geolocation. We could plot that on a map, and I could show you an example of that. We'll just add that to our graph. I'll try to add it to our graph. So here we've added like a couple of locations. That doesn't give us any more security information. It's just like useful, possibly, information. We can expand out on the graph. So we looked at if there were any alerts for our original user. What we haven't yet looked for is if there were any alerts related to the host or hosts that the user logged onto. And we find there are 8 of these. And they're somewhat repetitive, but not hugely. And now we've got like an interesting cluster around this host. So it's obviously has triggered multiple things that are not necessarily involved, not necessarily related to our original account. There's some other activity going on there that makes it kind of suspicious. And if I could scroll up, this is other data. These are the lists we were talking about, I think, before. And we can also do the same thing, like have any of these IP addresses also been triggered any alerts? And in this case, we've got one, what seems to be a very repetitive alert, or SSH anomalous logon. It seems to be naming the same IP address all the way through. So I did partly execute this stuff earlier on, and then because I had it all beautifully prepared last night, and then woke up this morning and opened my laptop, and it said, new updates have been installed. We've just cleaned out, we've just cleaned off all of your machine. Welcome, Ian. We're just getting things ready. So this has added our SSH anomalous logon as a kind of final thing. And in an Azure Sentinel environment, other things that might be interesting were things like, is this item already involved in an existing investigation? And we can query bookmarks that are kind of the marker for those things. Like, are they already part of an investigation case? That's probably something else we'd want to put on a graph. Now, we don't need to get this far, really, before we say, well, this is obviously bad stuff. We probably need to get an alert and maybe a TI indicator or as Matt said, like a few correlated alerts that are not triggered by the same activity, but there's some independent thing. We don't have a very pretty graph. There's some beautiful things that I've seen today. But we have something that's like relatively understandable. We can see what our origin, Ian, and all of the things that involved in. And I think this is rather than looking at a whole, big set of lists at the end, you can just present that as like, and you can, it's something you can present and talk around. Okay, so there are my very underwhelming graphs. Demo, I think I've already done that. And in conclusion, so graphs are, as I said, very powerful visualization tools. And I think some of the things I've heard today, there are techniques that I'm not using, there'll be most of them, that allow us to reveal attacker intent in ways that we would not otherwise be able to do. I think notebooks, using this to kind of pre-process and automate the whole investigation process around specific entities is a great way to speed up, how quickly we can get to our graph, and it reduces the whole kind of data overload, the need to work with Excel spreadsheets for data analysis. Not that I have anything against Excel, but I think there are better ways to do things. And finally, it provides like a really convenient storage and presentation thing. You've done your analysis, you've got a result, and you can show it to your manager, and they will understand what it is. And with that, I'll conclude. Thank you very much for staying around for the day. Oh, any questions? Yeah, I was going to say.
I wanted to open up the floor to see if you guys have any questions for Ian, and also open the floor more broadly for you guys to share any thoughts you had from your learnings today.
I know we're all very tired. I'm very tired. The end of the day. But it would be interesting if anybody else has got, like, unrelated to my stuff. Yeah.
Share any of your thoughts from today, anything you've learned, anything you thought was cool.
How good the food was.
Yes.
Just I thought it was very exciting to talk about, as an alternative and as a multiplier to help defenders with attackers. I mean, as somebody said earlier, that defenders have to be 100% right, but if you're using this, maybe that'll help even the odds.
Yeah, I think it was really encouraging that there was so many. Well, it was discouraging to me because as the last speaker, it was very encouraging to hear like lots of people talking about very similar things, usually in a better way than I talked about, but it was like you know, if enough people are thinking of roughly similar lines, then we're obviously either all completely mad or we're getting it right.
Yeah, it was a great. All of it was great about displaying relationships.
Mm-hmm.
Thank you for sharing.
I'll unplug and give because I'm.
Okay. Thank you, everyone, for coming. We're looking forward to seeing you guys tomorrow and the day after. Bye-bye.
Bye.